Yeah, the first thing, I'm very happy to be here and really excited. Last year I had the opportunity to talk as well for the first time. It was the first time container camping in Australia. And now I can see the things growing. We're in Melbourne and it's still having all these numbers. And I think if you are already working with containers, maybe 12 months ago wasn't reality, and now it's happening. And that's why, like 6-7 months ago, I just left my job to do that full time. Now I become some container guy. And it used to be my hobby. I used to be following this for the last 3 or 4 years, and then just became now my full-time job. And I put this talk because I think things are changing very fast, but still some things in Dockerfile, in Multistage build that we can discuss. But keep in mind that everything's moving fast. And I do all that stuff there, cloud development, DevOps, how you want to call that. I don't like DevOps, but integration and tech pre-sales, and I work now with Docker, Kubernetes, a lot of API background development as well. And I like that public speaking because I like to share my knowledge. I come from a generation that used to do that. It was before the Google generation. And we used to have to talk. If you don't talk with someone, you don't learn anything. And I think we have to do that again. And that's why I like to be here, because we have to be talking, sharing knowledge. Even if we have Google and all these YouTube, this video be on YouTube some stage. And we have to do that. And I like to be this community guy. And and help and learn a lot from everyone as well. And I'm a Microsoft Azure MVP since last year, and I was that Linux guy a long time ago, and moved from enterprise world and try to come back to that more hands-on and Linux thing again. And I put that agenda for today, like. Something I want to discuss, why we are all here. I think there is one reason, one single point in time that things start changing, and that's why we're here. That happened 5 years ago. Discuss some container flavors, and it's maybe a small introduction for the new people, because I like ours to onboard new people on that journey of containers. And I think that's important to go back to the basics sometimes. Try to be pretty quick on that, and moved for the talk that's Dockerfile in Multistage build. The next talk after myself here will be Abby, and she'll be talking more about Dockerfile. I'm trying to focus on Multistage build and and what's happening on that space, and try to show something running and see what's coming on the future. That's hard to say, but we can maybe discuss something. And that's why we're here. Anyone agree with that or not? I think I agree that at that point in time, the guy had 5 minutes to come here on a stage to talk about something he was doing. He used to work for this company, have this startup called .cloud, Solomon Hacks from Docker. He came here in 5 minutes on Docker Python conference, and he showed his wasn't open source yet, his personal project that became Docker. And he had 5 minutes to show that. Okay, I can't complain about my 25, 30 minutes here because he did. If you never watched that, that's the best inspiration talk for someone working with containers is watch these 5 minutes. 5 minutes and 21 seconds. He showed the Docker for the community for the first time. And the rest is history, but that's why I think we are here and should be grateful for what he did and still doing. And but Docker now is this thing, If you never heard about containers before, I'm pretty sure there are people here that are starting on containers now. And containers, Linux containers become that thing. And Docker was responsible to open source containerd and run C. That's pretty much who's creating the containers, and Dockerd is just like what we call Docker engine. And we use like some Linux features like namespace, LXC, Linux containers, all these things, to isolate your process. That's your container. Then a container is nothing more than a process with isolation on Linux, but that's Linux. Then Microsoft with Docker came like 2 or 3 years ago and started saying, let's bring that for Windows. And they started creating what they call Windows containers and Hyper-V containers. And the funny thing was like Hyper-V containers, virtualization layer around the container wasn't a thing. And a lot of people say, what's Microsoft's creating? But looks like now everyone is trying to do the same thing. And, but Windows containers is like Linux containers, same idea. And the Hyper-V, they have this lightweight virtualization around the containers. And that's pretty much how it works. And now they have a new flavor. They have what they call Linux container on Windows. Everything that I'm showing here, that's part of the Docker project, okay? Windows container, Linux containers, and Linux container on Windows. You can look on GitHub and you can see everything that's happening. And the source code is there. And now you can run Linux containers on Windows platform as well. It's a new flavor. Okay, and some people don't get at this, think that's just Linux containers, but there are a few flavors of those things. And that's how Microsoft implemented to create a very lightweight Linux VM. Using the open source projects to do that, and just communicate with that VM with the kernel of the operating system. And that's what we call that utility VM. Stateless, minimal kernel, lightweight VM, pageable memory, and but if you're a developer, you probably don't have to understand that. You're just going to use the product. But it's good to to understand that. And what's coming now? What's under development? What people call as well kata containers. It's kind of virtualization containers as well. There is a lightweight, virtualization there. And Google just released as open source what they call gvisor. And it's kind of a user mode kernel. You can sandbox your container with a user mode kernel. That's something you can follow. I'm not going in details. That's not my talk. But that's what containers is all about and is happening, And you don't have to understand everything, but just be aware of what's happening. And, now let's go back to the talk and Dockerfire. And we say that the container is a process, and on top like a Linux kernel or something. We talk about Linux containers here. Probably be talking only about Linux container today. And they create what they call Dockerfile. That's just like an instruction how you want to build the dependence to run your process. Okay, what you need to be installed. You start from like a scratch. You can say from scratch, and you start installing the Linux package, all the dependencies that you have to run your application. And at the end, they say you have a command just to run my application. That's what a Dockerfile is, nothing more. And they create this script, imperative language that you define whatever you want, starting from like a single point. And we normally never start from scratch, because luckily we have a few people developing Docker files and prepare what we call base images. Then that Golang is one base image if you want to build like a Go, source code. And what's inside that Golang is already dependence that you need to, build your application. Could be SDK, could be, some dependence that you need on top of the Linux kernel. And that's what like a Linux distro is some user mode that are dependence that you need to use that distro in a friendly way. And a container is the same thing. And the nice thing of this Dockerfile is that they are layers. Every time that you run something or copy something, they create like a file system layer. It's like an overlay of the file system, and one layer on top of the others. And they do the caching on that. then if you do the Docker build, that's nothing more than get this Docker file and create what we call a Docker image. It's like my template to run my application. Every time that I want to run this process, I get this Docker file, and I say Docker build. I create an image, and I run that image. Okay? That's really basic things, but it's very important. Otherwise, you're probably not going to follow the whole conference if you don't understand the basic. That's what a Docker file, Docker image is, and what people is talking about here. And like I said, once you build that the first time, they're going to get this Golang image from what we call Docker Hub. That's like a repository. Okay? If someone talk about Docker registry, nothing more than it's like a repository that Docker is hosting called Docker Hub. If you don't have an account, you should create right now after my session. Just create an account on Docker Hub and install Docker for desktop in your Mac or in your Windows. And by the way, I have a Windows here, it's not Mac. But I work with Mac as well. And going forward, and just for basic understanding what's a basic pipeline for containers is like having blue there on top. You get your Git repo, like your source code. Don't have to be Git, but everyone is using Git. And on that Git, you have your source code of your application, your microservice. And you have what do you call the Docker file that I just showed here. With this Docker file, the only thing we do a Docker build command. Okay, and we create these layers, image layers. And after that, you push that for like a Docker registry, like I said. And from Docker registry, you can run your containers as a serverless containers, as everyone is talking about now, or in a Kubernetes cluster, or in a local Docker. You can run these on any platform that can run a Docker image. And you're normally using those kind of tools. You can use Bash, kubectl for Kubernetes, Helm for Kubernetes, or any other Jenkins or whatever you want to use, CI/CD products, and to deploy this image as a container running somewhere. Okay, I'm not going into details on orchestrators or anything. Just Docker. You can have your laptop here, just install Docker, get Docker file, and you can do that yourself without knowing anything. And that's a normal pipeline. And see how I'm here. Yep. Docker Multistage build. At the beginning, we used to get a Docker file, and build the application, and use that image to run. And you don't have no difference between building and runtime. Okay, and everybody knows that we don't want to have all the SDKs and everything in production in runtime. And we used to have like what you call like two different Docker files. We first build the application, then we run that container, get the artifacts from the container, and we copy to a runtime, and we create another image. We used to do that doing a script. What you call people use, build partner, and was exactly like that. Was a script. And then Docker, exactly a year ago, was funny because it was released just a week before Container Camp last year. I think Ryan did like a lightning talk about this, but it was 5 minutes. And what we have now, we have this base image, the first from command, but now we can have multiple steps, okay? Each from run something, but only the last from is going to save the image, okay, on the repository. That's the only step. The last step will be the only one that's going to generate what we call a Docker image. And now what you can do, you can just say, You create like a basic image. You create your second step as your build step. Then you're going to, like that's a .NET one. You're going to copy your files, creating the layers. But that's not going to become anything. After you do your build, you just do another step and you start doing the publish. Then the publish is nothing more than copying everything that you need from the build step. And yep. And in .NET you have another thing that's published because .NET has build and publish. But at the end, the final image will be just pretty much your source code. The build, the artifacts that you need to run the application without any SDK dependency, without anything. What's the difference there? The difference is the image could be 800 megabytes, now become like in Go, like 10 megabytes. Okay? Even if you use Alpine, it's going to be 300 megabytes or 400 megabytes. And then if you remove all these SDK, all these things that you don't need in runtime, it's going to become, very tiny image. And it's not just the size. We all have lots of disk space and everything. But, when you need to scale the application very fast, and we need that container to be running in, milliseconds or microseconds, and we don't want all these dependence on your running container. Then you have to patch these things, you have to be scared about security, all these other things. And I think that's the main reason to remove all these things from the runtime image. And I tell you what, there are a lot of people not doing that yet. I saw that in production and many people not doing that stuff that maybe was released 1 year ago, but that's the reason for this talk. And the final step is exactly copying from any previous step. Okay, with this copy -- from, you can copy from any step. Let's say -- from the previous step, publish, just copy the application, and you have the final image there. And that's the main thing on like a multistage build. I think is the copy from with that -- from, and that's a very important thing. And for .NET, you have the entry point, like a command. And it means you can have as many steps as you want there. There's one nice thing as well. You can say, if you don't want to go to the final one, you just want to build your application and maybe run like some tests and see, just to see if it works. When you do a Docker build command, you can say target, and you can stop in a build step, for example. You don't have to go to the end. Okay? That's very important. Many people don't know that. And a multistage build, just say, for some reason, in development locally, I just stop there. Just stop there. I just want to make sure that's building properly, and that's it. And I don't care about the runtime yet, but I can use the same Docker file. I don't have to have a Docker file for development, a Docker file for production. It will be the same Docker file. I'm just stopping before the end. Okay, and that's very nice. Let's try show that running here. Like a Go samples, and I have 3 Docker files. If I open those Docker files, and you can see that the full one, and there's no Docker build stage, and we're just using like a Golang, not even using Alpine, and we're just building and running the application. That's nice, works, yes, works, but if you go something with Alpine, like this one, the same thing, just replacing for Alpine, it's still working. And if you go for multistage build, the same thing that we did on .NET, we're just going to build the application with like a full, Golang, even if it's Alpine, but still a full SDK. That's a very, hello world application. Maybe you have other dependencies in your application, but And after that first stage, the second one we call Alpine, that's the runtime one. And Go can run in Alpine image that's 4 megabytes. And you just put your application on top. And if you go back and you see the size now, Docker image, I did the build already. And you can see here, if you do Docker image server dash easy like that, yep. You can see the difference there. The full one is 800 megabytes. The simple one, just using the Alpine, is still 382. And you have the runtime with 10 megabytes. Okay? Maybe be a little bit more if you're using, SSL, all these things, and you need to install some other things, but that's the idea. That's how much you can go from 800 to like 10 megabytes. And I think that's a huge, huge difference. Another build that I did here was, I have another sample here with, I think, .NET. Yep. And what I did, I just built this .NET project. I want to show you probably the Docker file. What is that? CD web. By the way, I'm on Windows, but I'm using Linux. Windows subsystem for Linux. That's pretty much Ubuntu. And yep. And yeah, you see that I have a Docker file there. And the nice thing on this Docker file is we have more steps. You have now a step to build the application, but you have a step to test the application here. And you're going to use .NET test to run the tests. Then you're going to build, you're going to run the unit test, and then you can publish and have the final version. But if I'm developing in your local machine, you just say build and stop on that test. I just want to build and run my unit test. That's it. I don't want to go any further. I'm not going to publish. I just want to test if it's working. But in a real environment, not using, if you're doing Java, not using local Maven, using the Maven that's running inside your build process. That means that the result will be the same that's going to production. It's not runs on my machine and it's not running in production. No. If you do like that, and I was doing, even using Docker locally, it will always be working there. Okay, and if you look my Docker image here, you can do as many steps as you want. You can go. There are some images, that I think was Matt Farmer from Microsoft did, like for Twitter, and it's like Notify. You just create like a very simple Docker image with like a Go code just to send like a Slack message or a Twitter. And the only thing you have to set is send parameters there. And if you do a from inside your Multistage build, you can send notifications. Okay, you can do multiple things. And that's why my talk was going crazy with Docker Multistage build, because there are lots of variations that you can do on that steps. And if you combine that, I think, let me go back here for these slides. See, another nice thing, and I have to give the credit for, I put the credits on the slide at the end. There's a blog post a guy wrote about that. It means that he's using that in production. Okay, he's doing that. And I think it was very nice to show that. And what he's doing, he's using Docker Multistage build and on build. On build on Docker file is like an instruction just to run when you build the application. You create a Docker file and you say, when someone builds this Docker file, okay, they're going to execute these on build commands. Then what he did, he created like step 1, like a base builder. He created the step 2 like a runtime. And if you have, let's say that you have, I think like Go or Node or whatever you have, and you have like 20 or 100 microservice doing exactly the same thing. The folder structure is the same. They just need to copy the code. I think this guy, they have 50. They have 50 microservices, doing this thing. And he said, it's all the same. I have 50 Docker files that look exactly the same. I don't want to have 50 Docker files. And he did that. He used Multistage build with own build. And he's just, at the end, the number 3, that's a Docker file that all the 50 projects are using. And the other 2 are like base Docker files. But those own build commands are just running when you run the third one. Okay? And doesn't mean that you cannot have more things. On the number 3 there, you can have more things between those fronts. That's not part of the base ones. Okay? It's flexible. But they are hiding something from the developers or from the people that don't know how to write these things. And it's all kind of a template using Multistage build and on build. All the credits for him. I think it's Valerio, his name. I think from Canada. There's a link at the end. And see how much you have. And going forward with this, I think we have, if you look about Multistage build, you can do things like, Maven caching. Because in Docker build, you cannot mount like a volume. Not yet, maybe in a feature, you cannot do mounting like a volume with like maybe caching or something. But you could have this base image with everything that you need, all the dependencies inside, and you just put like a from in your Multistage build, and you copy whatever you want from there. Okay, that's another option. There are so many variations that you can do with a Docker Multistage build. And going forward, I believe on these container registry build, like Azure Container Registry build, Google Cloud Container build. The nice one from the Azure is that you can use the Docker file. You don't have to change anything that you already have. The Google will have to kind of just tell them then all these steps. It's similar, but there is no Docker file. The Microsoft one is like, it can be run from my local environment. I can say, can you run this build? They run on the public cloud, but they get all the context from my machine. Or you can say, I want to automate that with what you call GitOps things now. Everyone is talking about GitOps at KubeCon. And tools like Brigade that give you these, JavaScript, let's say, pipeline orchestration of steps, kind of what Multistage build is doing, but with more flexibility using JavaScript, and it's very powerful, by the way. You can share, artifacts from different steps, and that same idea. I think the future will be Brigade together with container registry, and they'll be combined in there some way. And if you guys are following Jenkins X and CodeFresh, they try to do similar things, and Jenkins X with kind of a GitOps approach, and it's still early stage. And there is a talk tomorrow about no Docker file approach, or we're going to talk about Builder. There's another way, you still can use Docker file, but maybe the feature will be no Docker files. And just about the container registry, because maybe people are interested, is the idea of those container registry building inside there is because the Docker registry is next to them. They're running something, and they can just push to the Docker registry. And that's exactly how it works. And they have kind of a triggers, like a GitOps. If you change your code, they're going to trigger builds. From that build, they're going to push to the Docker registry. Okay? And you can see that Brigade and CodeFresh, all these Jenkins, they all going to kind of, leverage these things as well. I think I see the features, and those container registry now, at least the Azure, the Microsoft one, you can have web hooks, like Docker Hub has, and you can kind of orchestrate, like say, when I push like my image, I just can trigger something just to run like a Helm chart and deploy my application. Then CI/CD has become very simple. Maybe for startups or small projects, maybe don't even need like a full CI/CD product if you use these things. And But products like, those are still helping a lot. And yeah, I put some links there.
Applause for Jorge.
Okay.